Linear regression versus logistic regression. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. In this video, we're going to cover the difference between the linear and logistic regression models. So what is in it for you? We're going to start with an introduction to regression. Then we'll go into an introduction to classification. What is linear regression? What is logistics regression? And then logistics versus linear regression. And we'll do a quick demo so you can see what the differences are and how they function. So when we start looking at regression, regression is literally talking about numbers. That's where that term comes from. And so regression is a statistical method which allows us to predict a dependent output variable based on values of independent input variables. And you can see here we have our independent input variables. In this case, our team in the back put together an image of a bunch of vegetables. It goes through the regression model or the recipe or the little programming setup, and then we have a dependent output variable. And so the output is based on what our input is and what we're looking for. So when we talk about, we're going to start with our introduction to classification. And so we want to start with our classification model. And we talk about the classification. Classification allows us to divide a given input into some predefined categories. The output is discrete value. It's distinct like 0, 1, true, false, or predefined output label class. And so you can see here we have our independent input variables, which is our bag of vegetables. It goes through our classification model. And it comes out and it says vegetables and different groceries, and so you have a categorical output variable. A lot of times when we're talking about programming, the broccoli would be one output, and it's either broccoli true or false. The carrot would be one output, and so forth. So if that is categorical, what is a linear regression? How does that have to fit all together? So linear regression is a machine learning model that is used to predict the values of output variables based on the value of the input variables. Consider the data given. And you can see here we have a group of data going up. And if you kind of mentally group it together, you can see there's a pattern, almost like a line. The input variable x are called independent variable and are used to predict the values of the response variable. The output variable y is called the dependent variable. Its value depends on the value of x. Linear regression aims to find the relationship between input and output variables by plotting a line which best fits the data given to it. Now, not all linear regression models use a line through the data. They use a lot of different ways to solve it. But when we talk about linear, they usually mean a line versus other different models. Regression means that we're going to be putting out a number. And you can see here we have our dependent variable y, and based on x, you can kind of guess what y is going to be. And this can be in 3 dimensions, 4 dimensions, 5 dimensions, so you might have multiple inputs. You might have a bunch of features coming in, and you're going to try to guess which one is going to have the right output for y and what that value is. The equation which can be used to fit a line is the equation of a straight line. The equation gives the output variable based on the input variable and inclination of the line. And you can see here we have y equals b naught, which is the y-intercept, y is our output, plus b1 of x plus e. And the b1 of x, that is our slope. If you remember from Euclidean geometry, usually you see y equals mx plus b. And then you have an error term. And the error term is pretty important because that's how we're going to calculate it. We want to find the error and minimize the error. Now this is a linear regression model. We're looking for a line. We only have one input. You can do this with multiple inputs. You can actually have a b1 x1 plus b2 x2 and so forth. There's a lot of different formulas they use to fit the model. The concept is important, that you're basically finding a mathematical formula that fits the data as best as you can and have minimal error. The data given represents the amount a company puts into advertisement and the resulting sales in thousands. Using regression, given the advertisement amount, we can predict how many sales it will take place. And you can see here, this is a very common one, very simple one. Most people, when you're looking at this kind of linear regression, do it by looking at it and saying, oh yeah, I can figure that one out. If I put $50 in, I'll get 100 cells. If I put $150 in, I get 275 cells. If I put $200 in, I get 300 cells. If I put $250 in, I get 400 cells. What is 175 going to be? And you can probably guess. You can probably look at this and guess, it'll be around 280 something, somewhere in there. With the help of linear regression, we can plot the graph of sales versus advertisement and find the line of best fit between them, and using that, find the values of the missing variable. And again, you can see right here, we know it's between 150 and 200. We know our data kind of has a nice linear increase, and you can, like I said, usually with something this simple, you eyeball it. But when we're talking about a business model, they get very complicated. You can have up to 26, 30 features in them. And so this simple model gives you an idea of what's going on, but when you try to eyeball something that complicated, you really need machine learning program to put it together. And you can see here where we're guessing the number of cells. So what is logistic regression? Logistic regression is a classification algorithm which is used to predict the category of dependent variable based on values of independent variable. Its output is 0 or 1. So if you remember, if we go back, you see here we're putting an output. We're going to look for, like I said, roughly 175. I guessed around 180, but 175 is what their guess was. You can actually do the math and have a more concrete number, but if you look at the variance of the data, that's a good guess. It's going to be somewhere in there. And so you can guess how much, you can predict how much marketing you need to put in to get those kind of cells. When we look at a regression model for category, a logistic, think category when you think logistic, you really want a 0, 1. I want a yes or no, true, false. Is this what it is, or it's not what it is? Consider the graph shown. The input values are of two types and are taken at 0 and 1. A threshold is set, which will be used to classify values into the two categories. Values of y above this threshold will be classified as category 1, and values below the threshold will be taken as category 0. Values of y above this threshold will be classified as category 1, and values below the threshold will be taken as category 0. The given equation is used to represent a sigmoid function. Y is the probability of an output, C is a constant, Y are the various dependent variables, and B0, B1 gives us the intercept values. And you can see here I was talking about earlier where you can have just a single input or you might have multiple inputs on here. This is with the sigmoid, it uses the log function of y over 1 plus y. And when you do that, it's going to give you a very clear answer. It's either going to be 0 or 1. There's a little discrepancy right in the middle, but for the most part, it's very clear which way it's going to go. And you can see here we have our intercept, our B naught, just like we did with our linear equation. And we have our input B1, X1, which is kind of like your slope. And then you have your constant C. The formulas are very similar. It's just how do we activate it? Do we give you the raw number, which tells you what percentage we think it's going to be, or do we convert it to a 0, 1 value? Consider credit card numbers and their transaction history. We want to classify the credit cards as fraudulent and legitimate. We can do this with logistic regression. This is a very common use of machine learning. It's actually a fairly simple problem to solve when you're looking at this kind of thing, because you have a huge history of what people are making as purchases. The bank can run it through one of these models and say, is it fraud or is it not? Should I put a hold on this and contact the customer, or should I let it go through because they're making their usual purchases? So consider the credit card numbers. We want to classify the credit cards as fraudulent. And so you can see here we have like a group that we put together, and like I said, they know they're fraudulent. These are fraudulent charges that they have incurred. The customer calls in and says, hey, cancel that charge, and you go through that nice fun thing of whether you have to pay for it or not, and how to block it, and how to get that money back. And you have all your good purchases you've done. One of the cool things about these two models And we talked, we're very brief talking about how they function, and you're just doing a sigmoid activation. There's different activations depending on what you're doing and how they function. Is that these are very simple to see. You can see how they work. And then you start taking these pieces and you can now build larger models. And you might have part of the model that predicts fraudulent, not fraudulent. And you might have the other part of the module that says, out of these fraudulent charges, what percentage of these, what's the cost going to be to the bank to cover them or not cover them? Or, I mean, there's a lot of different things that can mix in there. And so these are really a cool basis of where you start. And this is where right now pretty much all machine learning starts, is based on these two concepts. Even the most complicated ones start with this idea. And so there's a logic here that you should be noting versus just exactly, instead of looking at just a linear regression model, there's all kinds of regression models that come out of this. So when we put them side to side, we have our linear regression, which is a predictive number used to predict a dependent output variable based on independent input variable. Accuracy is measured using least squares estimation. So that's where you take, you could also use absolute value. The least squares is more popular. There's reasons for that mathematically and also for computer runtime. But it does give you an accuracy based on the least square estimation. The best fit line is a straight line. And clearly that's not always used in all the regression models. There's a lot of variations on that. The output is a predicted integer value. Again, this is what we're talking about when we talk about linear regression. And we're talking about regression, it means the number's coming out. Linear usually means we're looking for that line versus a different model. And it's used in business domain, forecasting stocks. It's used as a basis of most predictions with numbers. So if you're looking at a lot of numbers, you're probably looking at a linear regression model. For instance, if you do just the high lows of the stock exchange, and you're going to take a lot more of that if you want to make money off the stock, you'll find that the linear regression model fits probably better than almost any of the other models, even high-end neural networks and all these other different machine learning and AI models, because they're numbers. They're just a straight set of numbers. You have a high value, a low value, volume, that kind of thing. So when you're looking at something that's straight numbers and are connected in that way, usually you're talking about a linear regression model, and that's where you want to start. A logistic regression model used to classify dependent output variable based on independent input variable. So just like the linear regression model and like all of our machine learning tools, you have your features coming in. And so in this case you might have label, an image or something like that is probably the very popular thing right now, labeling broccoli and vegetables or whatever. Accuracy is measured using maximum likelihood estimation. The best fit is given by a curve. And we saw that when we're talking about linear regression, you definitely are talking about a straight line, although there is other regression models that don't use straight lines. And usually when you're looking at a logistic regression, the math, as you saw, was still kind of a Euclidean line, but it's now got that sigmoid activation, which turns it into a heavily weighted curve. And the output is a binary value between 0 and 1. And it's used for classification. Image processing, as I mentioned, is what people usually think of, although they use it for classification of like a window of things. So you could take a window of stock history and you could generate classifications based on that and separate the data that way. If it's going to be that this particular pattern occurs, it's going to be upward trending or downward trending. In fact, a number of stock traders use that not to tell them how much to bid or what to bid, but they use it as to whether it's worth looking at the stock or not, whether the stock's going to go down or go up. And it's just a 0 or 1. Do I care? Do I even want to look at it? So let's do a demo so you can get a picture of what this looks like in Python code. Let's predict the price at which insurance should be sold to a particular customer based on their medical history. We will also classify on a mushroom dataset to find the poisonous and non-poisonous mushrooms. And when you look at these two datas, the first one, we're looking at the price. So the price is a number. So let's predict the price which the insurance should be sold to. And the second one is we're looking at either it's poisonous or it's not poisonous. So first off, before we begin the demo, I'm in the Anaconda Navigator. In this one, I've loaded the Python 3.6 and using the Jupyter Notebook. And you can use Jupyter Notebook by itself. You can use the Jupyter Lab, which allows multiple tabs. It's basically the notebook with tabs on it. But the Jupyter Notebook is just fine, and it'll go into Google Chrome, which is what I'm using for my Internet Explorer. And from here we open up new, and you'll see Python 3, and again this is loaded with Python 3.6. And we're doing the linear versus logic regression, or logit. You'll see L-O-G-I-T is one of the names that kind of pops up when you do a search on here. But it is a logic. We're looking at the logistic regression models. And we'll start with the linear regression because it's easy to understand. You draw a line through stuff. And so in programming, we got a lot of stuff to unfold here in our startup as we preload all of our different parts. And let's go ahead and break this up. We have at the beginning import pandas. So this is our data frame. It's just a way of storing the data. Think of when you talk about a data frame, think of a spreadsheet. You have rows and columns. It's a nice way of viewing the data. And then we have, we're going to be bringing in our preprocessing label encoder. I'll show you what that is. When we get down to it, it's easier to see in the data, but there's some data in here like sex. It's male or female, so it's not like an actual number. It's either you're one or the other. That kind of stuff ends up being encoded. That's what this label encoder is right here. We have our test split model. If you're going to build a model, you do not want to use all the data. You want to use some of the data and then test it to see how good it is. And if it can't have seen the data you're testing on until you're ready to test it on there and see how good it is. And then we have our logistic regression model, our categorical one, and then we have our linear regression model. These are the two, these right here. Let me just clear all that. There we go. These two right here are what this is all about. Logistic versus linear. Is it categorical? Are we looking for a true false, or are we looking for a specific number? And then finally, usually at the very end, we have to take and just ask how accurate is our model. Did it work? If you're trying to predict something, in this case we're going to be doing insurance costs. How close to the insurance cost does it measure that we expect it to be? You know, if you're an insurance company, you don't want to promise to pay everybody's medical bill and not be able to. And in the case of the mushrooms, you probably want to know just how much at risk you are for following this model as far as whether you're going to eat a poisonous mushroom and die or not. So we'll look at both of those, and we'll talk a little bit more about the shortcomings and the value of these different processes. So let's go ahead and run this. This is loaded the data set on here, and then because we're in Jupyter Notebook, I don't have to put the print on there. We just do data set, and it prints out all the different data on here, and you can see here for our insurance, because that's what we're starting with, we're loading that with our pandas, and it prints it in a nice format where you can see the age, sex, body mass index, number of children, smoker. So this might be something that the insurance company gets from the doctor. It says, hey, this is what we need to know to give you a quote for what we're going to charge you for your insurance. And you can see that it has 1,338 rows and 7 columns. You can count the columns, 1, 2, 3, 4, 5, 6, 7. So there's 7 columns on here. And the column we're really interested in is charges. I want to know what the charges are going to be. What can I expect? Not a very good arrow drawn. What to expect them to charge on there. So is this going to be, is this person going to cost me $16,884, or is this person only going to cost me $3,866? How do we guess that so that we can guess what the minimal charge is for their insurance? And then there's one other thing you really need to notice on this data. and I mentioned it before, but I'm going to mention it again because pre-processing data is so much of the work in data science. Sex. Well, how do you deal with female versus male? Are you a smoker? Yes or no? What does that mean? Region. How do you look at region? It's not a number. How do you draw a line between southwest and northwest? You know, they're objects. It's either your southwest or your northwest. It's not like I'm southwest. I guess you could do longitude and latitude, but the data doesn't come in like that. It comes in as true, false, or whatever. You know, it's either your southwest or your northwest. So we need to do a little bit of pre-processing of the data on here to make this work. Oops, there we go. Okay, so let's take a look and see what we're doing with pre-processing. And again, this is really where you spend a lot of time with data science, is trying to understand how and why you need to do that. And so we're going to do, you'll see right up here, label. And then we're going to do a label encoder, one of the modules we brought in. So this is sklearn's label encoder. I like the fact that it's all pretty much automated, but if you're doing a lot of work with the label encoder, you should start to understand how that fits. And then we have label.fit right here, where we're going to go ahead and do the dataset .sex.drop duplicates. And then for dataset sex, we're going to do the label transform the dataset sex. And so we're looking right here at male or female. And so it usually just converts it to a 0 or 1 because there's only 2 choices on here. Same thing with the smoker. It's 0 or 1, so we're going to transfer the change the smoker 0 or 1 on this. And then finally we did region down here. Region does it a little bit different. We'll take a look at that, and I think in this case it's probably going to do it because we did it on this label transform. With this particular setup, it gives each region a number, like 0, 1, 2, 3. So let's go ahead and take a look and see what that looks like. Go ahead and run this. And you can see that our new data set has age, that's still a number. Sex is 0 or 1, so 0 is female, 1 is male. Number of children, we left that alone. Smoker, 1 or 0. It says no or yes on there. We actually just do 1 for no, 0 or no. Yeah, 1 for no. I'm not sure how it organized them, but it turns the smoker into 0 or 1, yes or no. And then region, it did this as 0, 1, 2, 3. So it's 3 regions. Now, a lot of times when you're working with data science and you're dealing with regions or even word analysis, instead of doing one column and labeling it 0, 1, 2, 3, a lot of times you increase your features. And so you would have region northwest would be 1 column, yes or no. Region southwest would be 1 column, yes or no. True, 0, 1. But for this particular setup, this will work just fine on here. Now that we spent all that time getting it set up, here's the fun part. Here's the part where we're actually using our setup on this, and you'll see right here we have our y-linear regression dataset drop the charges, because that's what we want to predict. And so our x linear data set drop the charges, because that's what we're going to predict. We're predicting charges right here, so we don't want that as our input for our features. And our y output is charges. That's what we want to guess. We want to guess what the charges are. And then what we talked about earlier is we don't want to do all the data at once, so we're going to take 0.3, means 30%. We're going to take 30% of our data, and it's going to be as the testing site. So here's our y test and our x test down there. And so that part, our model will never see it until we're ready to test to see how good it is. And then of course right here you'll see our training set, and this is what we're going to train it. We're going to train it on 70% of the data. And then finally the big ones, this is where all the magic happens. This is where we're going to create our magic setup, and that is right here. Our linear model, we're going to set it equal to the linear regression model, and then we're going to fit the data on here. And then at this point, I always like to pull up If you're working with a new model, it's good to see where it comes from. And this comes from the scikit-learn, and this is the sklearn linear model, linear regression that we imported earlier. And you can see they have different parameters. The basic parameter works great if you're dealing with just numbers. I mentioned that earlier with stock, high-lows. This model will do as good as any other model out there if you're doing just the very basic high-lows and looking for a linear fit, a regression model fit. And one of the things when I am looking at this is I look for methods. And you'll see here's our fit that we're using right now, and here's our predict. And we'll actually do a little bit in the middle here as far as looking at some of the parameters hidden behind it, the math that we talked about earlier. And so when we go in this, we go ahead and run this, you'll see it loads the linear regression model and just has a nice output that says, hey, I loaded the linear regression model. And then the second part is we did the fit. And so this model is now trained. Our linear model is now trained on the training data. And so one of the things we can look at is for IDX and column name and enumerate X linear trained columns. Kind of an interesting thing. This prints out the coefficients. So when you're looking at the back end of the data, you remember we had that formula, bxx1 plus bxx2 plus the intercept, and so forth. These are the actual coefficients that are in here. This is what it's actually multiplying these numbers by. And you can see like region gets a minus value, so when it adds it up, I guess region. You can read a lot into these numbers. It gets very complicated. There's ways to mess with them. If you're doing a basic linear regression model, you usually don't look at them too closely. But you might start looking in these and saying, hey, you know what, smoker, look how smoker impacts the cost. It's just massive. So this is a flag that, hey, the value of the smoker really affects this model. And then you can see here where the body mass index, so somebody who is overweight is probably less healthy and more likely to have cost money. And then of course age is a factor, and then you can see down here we have sex is then a factor also, and it changes as you go in there. Negative number, it probably has its own meaning on there. Again, it gets really complicated when you dig into the workings and how the linear model works on that. And so we can also look at the intercept. This is just kind of fun. So it starts at this negative number and then adds all these numbers to it. That's all that means. That's our intercept on there. And that fits the data we have on that. And so you can see right here, we can go back and, oops, give me just a second. There we go. We can go ahead and predict the unknown data, and we can print that out. And if you're going to create a model to predict something, we'll go ahead and predict it. Here's our Y prediction value, linear model predict. And then we'll go ahead and create a new data frame. In this case, from our X linear test group, we'll go ahead and put the cost back into this data frame. And then the predicted cost, we're going to make that equal to our Y prediction. And so when we pull this up, you can see here that we have the actual cost and what we predicted the cost is going to be. There's a lot of ways to measure the accuracy on there, but we're going to go ahead and jump into our mushroom data. And so in this, you can see here we've run our basic model. We've built our coefficients. You can see the intercept, the back end. You can see how we're generating a number here. Now with mushrooms, we want a yes or no. We want to know whether we can eat them or not. And so here's our mushroom file. We're going to go ahead and run this, take a look at the data. And again, you can ask for a copy of this file. Send a note over to simplilearn.com. And you can see here that we have a class, the cap shape, cap surface, and so forth. So there's a lot of feature. In fact, there's 23 different columns in here going across. And when you look at this, I'm not even sure what these particular, like PEE, PE, I don't even know what the class is on this. I'm going to guess by the notes that the class is poisonous or edible. So if you remember before, we had to do a little pre-coding on our data. Same thing with here. We have our cap shape, which is B or X or K. We have cap color. These really aren't numbers, so it's really hard to do anything with just a single number. So we need to go ahead and turn those into a label encoder, which again, there's a lot of different encoders. With this particular label encoder, it's just switching it to 0, 1, 2, 3 and giving it an integer value. In fact, if you look at all the columns, all of our columns are labels. And so we're just going to go ahead and loop through all the columns in the data, and we're going to transform it into a label encoder. And so when we run this, you can see how this gets shifted from XBXXK to 0, 1, 2, 3, 4, 5, or whatever it is. Class is 0, 1, 1 being poisonous, 0 looks like it's editable, and so forth on here. So we're just encoding it. If you were doing this project, depending on the results, you might encode it differently. Like I mentioned earlier, you might actually increase the number of features as opposed to labeling it 0, 1, 2, 3, 4, 5. In this particular example, it's not going to make that big of a difference how we encode it. And then, of course, we're looking for the class, whether it's poisonous or edible. So we're going to drop the class in our X logistics model, and we're going to create our Y logistics model is based on that class. So here's our XY, and just like we did before, we're going to go ahead and split it using 30% for test, 70% to program the model on here. And that's right here. Whoops, there we go. There's our train and test. And then you'll see here on this next setup, this is where we create our model. All the magic happens right here. We go ahead and create a logistics model. I've upped the max iterations. If you don't change this for this particular problem, you'll get a warning that says this has not converged. Because that's what it does, is it goes through the math and it goes, hey, can we minimize the error? And it keeps finding a lower and lower error, and it still is changing that number. So that means it hasn't converged yet. It hasn't found the lowest amount of error it can. And the default is 100. There's a lot of settings in here. So when we go in here to, let me pull that up from the sklearn. So we pull that up from the sklearn model. You can see here we have our logistic. It has our different settings on here that you can mess with. Most of these work pretty solid on this particular setup, so you don't usually mess a lot. Usually I find myself adjusting the iteration, and I'll get that warning and then increase the iteration on there. And just like the other model, you can go, just like you did with the other model, we can scroll down here and look for our methods. And you can see there's a lot of methods available on here. And certainly there's a lot of different things you can do with it. But the most basic thing we do is we fit our model, make sure it's set right, and then we actually predict something with it. So those are the two main things we're going to be looking at on this model, is fitting and predicting. There's a lot of cool things you can do that are more advanced, but for the most part, these are the two which I use when I'm going into one of these models and setting them up. So let's go ahead and close out of our sklearn setup on there, and we'll go ahead and run this. And you can see here it's now loaded this up there. We now have a logistic model, and we've gone ahead and done a predict here also, just like I was showing you earlier. So here's where we're actually predicting the data. So we've done our first two lines of code as we create the model. We fit the model to our training data, and then we go ahead and predict for our test data. Now, in the previous model, we didn't dive into the test score. I think I just showed you a graph, and we can go in there, and there's a lot of tools to do this. We're going to look at the model score on this one. And let me just go ahead and run the model score. And it says that it's pretty accurate. We're getting a roughly 95% accuracy. Wow, that's good. 95% accuracy. 95% accuracy might be good for a lot of things. But when you look at something as far as whether you're going to pick a mushroom on the side of the trail and eat it, we might want to look at the confusion matrix. And for that, we're going to put in our Y logistic test, the actual values of edible and unedible, and we're going to put in our prediction value. And if you remember on here, let's see, I believe it's poisonous was 1, 0 is edible. So let's go ahead and run that. 0, 1. 0 is good. So here is a confusion matrix, and this is, if you're not familiar with these, we have true, 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 false, true, false, false, false. So it says out of the edible mushrooms, we correctly labeled 1,201 mushrooms edible that were edible. And we correctly measured 1,113 poisonous mushrooms as poisonous. But here's the kicker. I labeled 56 edible mushrooms as being poisonous. Well, that's not too big of a deal. We just don't eat them. But I measured 68 mushrooms as being edible that were poisonous. So probably not the best choice to use this model to predict whether you're going to eat a mushroom or not. And you'd want to dig a little deeper before you start picking mushrooms off the side of the trail. So a little warning there, when you're looking at any of these data models, looking at the error and how that error fits in with what domain you're in, domain in this case being edible mushrooms, be a little careful. Make sure that you're looking at them correctly. So we've looked at edible or not edible. We've looked at regression model as far as the end values, what's going to be the cost and what our predicted cost is, so we can start figuring out how much to charge these people for their insurance. And so these really are the fundamentals of data science. When you pull them together, when I say data science, I'm talking about your machine learning code. And hopefully you got a little bit out of here. Again, you can contact our Simplilearn team and get a copy of these files or get more information on this. So that wraps up our demo for today. Thank you for joining us at Simplilearn. For more information, please visit Simplilearn.com, www.simplilearn.com. Get certified, get ahead.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.